Hello everybody and welcome to the statistics lecture. So with this particular one, it's a very important topic because some psychologists have referred to statistics, which is a form of math, as the lifeblood of psychology. Every single research study uses statistics to sort of prove their point, to sort of prove that that there's, for example, a pattern of behavior, or that there is not random behavior. Also, we need to know what the average score is for intelligence, or it tells us what normal is and what normal is not. It really helps us prove our point, essentially, in our experiment or research study. So let's hop to it. We're going to look at all these lesson objectives as quickly as we can. I'm going to shoot for 10 minutes. Please focus on correlation efficiency. I'm going to spend a little more time on that. Your homework will be on that. I'll show you the homework right now. Let's see. Let me get out of this real quick and show you. Okay, so this is what the homework is going to look like. And I need you to be able to know what a correlation is, what a negative correlation is, a positive correlation. And you need to follow the directions. And you'll be given examples, and you have to indicate whether it's positive or negative, and offer other alternative explanations. So, with that, let's head back into the lecture. Okay. First and foremost, statistics is a branch of mathematics, and it's concerned with the collection and interpretation of numerical data. Now, most psychological studies will collect data or information from large groups of people. Now, we can't look at each person's information one by one. Most of the time, we want to take all the data, all the information from all the people, and use it to make a statement about the group. One of those ways is, for example, an average. So if 1,000 people take an intelligence test, we don't want to know the scores of every single person. We want to know the average score. An average is a statistic. And so statistical analysis also, to another level, establishes how much error there is in a particular study. For example, did we achieve our data by random? So, for example, those 1,000 people who took an intelligence test, did they just answer the questions randomly? Or did they only answer some of them randomly, or guess some of the questions? Statistical analysis can provide us with answers that we wouldn't ordinarily be able to just by looking at individual test scores. So, descriptive statistics, again, now these are statistics that describe behavior and can also provide patterns and provide good summaries for general behavior of a large group, especially a large group of data, that we hope that we can generalize to a larger population. Now, measures of central tendency, this is an important one. This is what we use to summarize data and give you one score that seems to be typical of the sample. So again, a mean or an average is a perfect example. We have 1,000 people take a IQ test to test their average, and the average score is 100. So if, for example, I were to look at someone who I think has normal intelligence, I could make an educated guess that that person probably has an IQ of around 100. And average scores are very useful for this because then I know what to expect, what is normal. What should I set my standard as for my definition of intelligence, for example. Median and mode. I'll let you pause on this if you want to look at this, but it's not really too important right now. Same thing with kind of range and standard deviation, but I will say standard deviation and range. When you collect data from 1,000 people, you're going to have a very low score and a very high score, and your range means the difference between your highest score and your lowest score. So, for example, if the lowest score was 40 and the highest score was 150, then your range is about 110. And so standard deviation is a statistical measure of the average variation from the mean score. Now, when we say average variation, variation means different. Deviation means to go away from, or how far away you are. So when we look at different people's scores, so for example, if I wanted to look at my own score in an intelligence test, I want to know how far away my score is from the average score. If it's very close, then the standard deviation is going to be low. But if my standard deviation is very far away, if my intelligence score is very far away from the average, then my standard deviation is going to be high. So, there are many different graphs that you can use to represent your data. So, for example, there's a frequency distribution, a histogram, which is a bar graph, and a polygon, which is a line graph. There's also a bell curve. Now, the bell curve is the gold standard in psychology, and we try to represent data, for example, from intelligence tests, into a bell curve type of graph. Let me show you. So, for example, this is a frequency distribution. This is a perfectly acceptable way of representing your data, but it's kind of plain Jane. Now we have this one. This is the histogram. It's also a bar graph, is the more common name for it. Now you can really see the pattern. So if you're in this example, it seems down at the bottom here, we have glasses of water, and it seems 6 glasses of water seems to be the average or most common. Also, it seems that, whoops, I went back a little bit, sorry guys. That seems to suggest that 6 people have 6 glasses of water. That seems to be the average. So most people have 6 glasses. Very few people have only 2 glasses of water a day, and very few people have 10 glasses of water a day. And so maybe these 5 bars right here seem to be a normal range of water drinking. We have this line graph here. This is also an appropriate one. But, again, this is a normal curve, or a bell curve, because it's shaped like a bell. And it's the golden standard. Now, what's important to know here is, especially for an intelligence test, a bell curve is very useful for identifying who is very intelligent and who is not very intelligent. The way you know this is standard deviation -2 and standard deviation +2. Now, everyone between 2 and -2, that represents about 95% of all people who took a test. So anyone who scored down here is very far away from the average score and probably has some special needs. Anyone who scored up here is probably very intelligent and is gifted and probably needs to go to college instead of high school. Now, correlation. Here's the part we're going to try and focus on, because I know I'm running about 8 minutes or so. A correlation is a measure of the relationship between 2 variables. So, for example, is studying time related to your grades? So, in other words, if you spend more time studying, will you get better grades? Is there a relationship between those 2 variables, those 2 things? We use a formula to determine what's called the correlation coefficient. And the correlation coefficient tells us the strength of the relationship, how strong is it, and also the direction of the relationship between variables. And when we say direction, we mean sort of like cause and effect. So, for example, does good grades cause you to study more? Do people who get good grades study more? Or does putting in the time give you the good grades? Both of those explanations could be true, but we're not sure. But a correlation coefficient will give us some idea of which of those 2 is probably most true. Now, a positive correlation, and really focus on this one, when you have 2 variables, if one increases, the other increases. So if I study more, if I spend more hours studying, I'll probably get a better grade. Now, on the other side, if I spend less time studying, or if I spend no time studying, I'm going to get a lower grade or a very bad grade on a test or in a class. Now, a negative correlation, here's where it gets a little confusing. When one goes up, the other goes down, or when one goes down, one goes up. So, for example, school absences. You're not at school. So if you miss school days, your grades are probably going to go down because you're not in school, you're not turning in homework, you're not doing tests. But if, for example, if your absences are low, or if you have no absences, your grades are probably going to go up because you're in school and you're doing your grades. You're doing your homework and you're doing your classwork and you're getting good grades. Now with these, don't worry too much about the numbers, but 1.0 represents, or negative 1.0 or positive 1.0 represents 100%. That means if you get a correlation coefficient of 100, that means these two variables are absolutely 100% related, and they're very, 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 very strongly related. Now if it's 0, on the other hand, they're not related at all. Now, if you look at these correlations here, you notice on the top you'll see positive correlations, and on the bottom you'll see negative correlations, and on the top right you'll see no correlation at all. It looks almost as if it's random. Now, in a perfect world, on the left side, over here, this is what a positive correlation looks like, and also what a negative correlation looks like. But in reality, this is what you're going to find in the real world when you do real correlations. Now, with inferential statistics, you take the statistical analysis of 2 or more sets of numerical data to reduce the possibility of error in measurement and to determine if the differences between the data sets are greater than the chance variation would predict. So what does this mean? If I were to take an intelligence test of Arroyo Pacific Academy students, and if I were also to have Arcadia High take intelligence tests, that means I have 2 sets of data. Now, I want to compare them. I want to compare the intelligence of Arroyo Pacific Academy students to Arcadia High students. And what I want to see is there a meaningful difference? Are we smarter than Arcadia High, or are Arcadia High students smarter than us? Or is there no difference at all? Inferential statistics can tell us that. So, for example, if the scores of Arcadia High are very high, then we have what's called statistical significance. And there's a way to test for this. We want to make sure that the data that we got was not random, was not caused by random variation. And this is also to say that it wasn't caused by an error or mistake. And the golden rule here is that researchers are satisfied when tests indicate that there's a 95% likelihood that the experiment results did not occur by chance. In other words, that they did happen for a reason. And when you do these studies, you're definitely going to look for a value of 5% or less that the results were due to random. So, for example, when I say random, I mean someone just went C, 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 entered all the C answers. That would be random. Finally, let's look at reliability and validity. Reliability of a psychological test and validity of a psychological test. Now, when we give a test to someone in a psychology experiment, we want to know that it's reliable. So I can give this test many different times to many different people, and it will give me the same results and same scores again and again over time. Now, validity is the degree to which it actually measures what it's supposed to measure. So, for example, if I am trying to measure happiness, and I give you a test on how many cheeseburgers you eat in 1 week, that's not actually going to measure happiness. It's a weak measure, so it's going to have low validity. It's very, very important that when you do a psychological research study, that you use tests that are both reliable and valid. We'll look at these 2 ideas on Monday and Tuesday. Have a good weekend. Don't forget to do the homework.